Our next session is brought to you by two members of the team at SICK Sensor Intelligence. Praveen Kannan is National Product Manager at SICK Sensor Intelligence, who specializes in Industry 4.0, sensing and machine vision technologies. He has implemented hundreds of Industry 4.0 systems in manufacturing and supply chain operations. Gary Milburn joined SICK in early 2013 as the Market Product Manager for Industrial Safety. He has over 30 years experience with machinery safety and is a certified SGS TUV safety application expert. It is now with great pleasure that I welcome your next speakers, Praveen and Gary.
Thank you, Dan, for the introductions.
Thank you, Dan, for the introduction. Also, I'll come in with my presentation after Praveen's finished his presentation.
Thank you, Gary. A little background about SICK. So we are a world's leading sensor manufacturer with headquarters in Germany. We were founded by Dr. Erwin Sick. Erwin Sick is an inventor as well as an entrepreneur. The company was founded in 1946. Over the years, we have built products in the areas of sensing, identification, which is the code reading, RFID, measurement devices, including LiDAR for autonomous navigation, protection devices, safety light curtains, and so forth. And of late, we have been specializing in the areas of data integration. We have a smart edge computing device as well as a controlling device. In Australia, we primarily operate in three markets. The factory automation, which is the fast-moving consumer goods, including food and bev. In the logistics, we work heavily with courier, express post, as well as retail distribution. And in the process industry, we work with oil and gas and mining customers. Some of our customers in the logistic automation space includes some of the largest distribution centers, postal handling services. We also work, as I mentioned, heavily with some of the named customers in retail, as well as large system integrators in the areas of storage, conveying, and so forth. So the agenda for today includes a walkthrough of industry trend. I'll talk about the industry trend, what is impacting the supply chain industry, primarily in the areas of digital twin. I will then go into why the digital supply chain twin in the areas of logistics and distribution. Some of the use cases that SICK has been working on, as well as our customer has been talking to us. I'll jump upon a couple of success stories and then followed by Gary, who will talk about the 3D safety concept. So to set the context for everyone in the audience, what is the digital supply chain twin? Digital supply chain twin is a category recently identified by Gartner in 2021. There's a lot of technology providers as well as chief digital officers looking at this category quite closely. And for me, digital supply chain twin is a fingerprint of your supply chain, which can include the items or the products, the assets, the returnable assets, or the fixed assets, including forklift, processes that can also be part of the digital twin ecosystem, as well as location. So we have smart locations in the areas of providing advanced navigations as well as indoor localization. Industry trend. I picked up a recent study from Gartner. Gartner has been talking about the latest supply chain technology trends for 2021. The first area they've been focusing on is the digital supply chain twin. And they are saying digital supply chain twin is an ever increasing merger of both physical and digital world. And some of the analysts in the Gartner report have been talking about an exploration of digital twin in the APAC market. The next area Gartner has been talking about is around continuous intelligence. I think continuous intelligence will enable organization to accelerate their digital transformation. And that's certainly going to be very important focus as the companies go towards post-COVID normal. The last one is the immersive experience, which is the convolution of virtual reality technology as well as gaming technology into the supply chain. And SICK as well as other companies in this area have been working on providing a virtual reality-based experience in terms of providing services and support to our customers. Other market studies, I have a study from Markets and Markets. They've been talking about significant growth in digital twin in the next decade, mainly coming from the APAC region, about 60% growth post-COVID. Of course, Australia and New Zealand is part of the APAC community. Another study, which I think is very interesting, is from the Boston Consulting Group. They are talking about at least a 5% saving on supply chain cost. These costs can include a reduction from the inventory, which is a significant portion, but also reduction in the capex, where they're talking about reduced capital expenditure or making more of your existing capital investments, so making more throughput and so forth, which finally will lead to some EBITDA improvements around 1 to 3%. The last study is from Ernst & Young. Their number one challenge by most of the chief supply chain officers and digital officers is around providing end-to-end visibility. The study is quite staggering, only 6% worldwide. I think this number is going to be a lot lower in our market. We are confidently able to say they have a full end-to-end supply chain visibility. I think this is an area that's going to grow very fast post-COVID, and there's a lot of catch-up to do. Okay, so what is real-time visibility? Real-time visibility is in the center of pyramid for us. It is combining the data from the sensor network, be it barcode scanners, weighing system, dimensioning systems, and so forth, along with the business systems. These are your warehouse execution system, enterprise resource planning system, ERP systems, and so forth. Combining this data provides digital twin. And in the center of that is the real-time visibility. Why is real-time visibility important? As we talked in the previous slide, this is going to be the number one trend most of the supply chain and the digital offices will be looking at. All right, let's talk about digital supply chain twin. What is a digital supply chain twin and how do we achieve it? There are 5 steps in terms of achieving it. The various processes that evolves in terms of achieving it. The first one is around enabling visibility. This is about providing real-time information for your assets and the processes as well as material flow. The second one is around providing a real-time locationing or a continuous tracking of physical transaction within your warehouse and distribution center. The next area is around improving transparency. Improving transparency is around minimizing any gray spots, especially in a complex supply chain. There's a lot of document exchange between one transaction to the other. We certainly want to minimize the gray spots. And then the second area is around less searching. Time and again, our customers, as well as the large companies, do struggle in terms of finding the right item or finding the right documentation and so forth. So searching, providing that enhanced search capability is very critical. The third step is around making it predictable. So once you have the visibility and transparency, how can we make it predictable? When we talk about predictability, this is around real-time estimation of your consignment, minimizing idle time, be it your assets as well as in the processes, removing bottlenecks. Inventory management is a key. We talked about what the analysts were talking about, a 5% reduction in the inventory. Having an efficient inventory management is critical in terms of making it predictable. And then the last area is around having real-time alerts and notification directly delivered to all kinds of devices in this context. And finally, when we make it predictable, it's all about process efficiencies and improvement. And some of the process efficiencies that we have seen is definitely in automating of documentation, automating of your goods receival and verifying shipment at the dock door, faster responses to unexpected events, such as the pandemic. Classic examples, we've been working with a customer in North America who are making ventilators and trying to make decisions around where to put these resources based on the hotspots they have. And the IoT technology and the digital twin behind it really help them in terms of managing these critical assets, which has a time factor to it, of course, an unexpected event. So as an example, a great technology would be digital twin in terms of managing those critical assets. And which also talks about being more efficient with your assets. So that's a four-step process in terms of how do we achieve a supply chain digital twin. Where does SIG play? SIG play a key role in terms of enabling digital twin. So we have a number of components that would achieve that. What you see on the top part is a virtual representation of a supply chain where the demand comes from the consumer, where the manufacturer parts build up the supply. And this constant back and forth between the consumer and the manufacturer is enabled through these convoluted supply chain network, which includes distribution center, transportation, retailers, and so forth. So in order for us to achieve the real-time visibility through digital twin, it's important to have data collection through sensing, through identification, through dimensioning. When I say dimensioning includes weighing as well, so dimensioning and weighing, and finally scanning. So all these technology together in the supply chain do provide that real-time visibility so that the demand and the supply forces are evened out. So that's one way of how supply chain digital twin works. It's automating these data collection points. So a little bit more in terms of the technology offering. So we have an empowered edge, which is collecting all this data, making decisions in the real time, enabling processes and people to be more efficient, more productive, a lot more throughput of your existing infrastructure. All of our sensing, scanning, encoding, dimensioning system do bring into our smart edge data collection system, which processes these data, make real-time notification, etc. Do the self-healing or course correction as it required. Further, it can also be integrated with the cloud. We also use some of the newest artificial intelligence, deep learning techniques to massage the data, to process the data, to extract even more value of the data that you collected. So this is a conceptual representation of how a technology stack that would support the supply chain digital twin will work. So let's jump into some of the use cases. So I have actually two slides of these use cases. The first one I want to talk about is around the dimension weighing and scanning system. Dimension weighing scanning system provides an opportunity for the item in the supply chain to have a digital representation in either the cloud or the customer network. So in this case, imagine a consumer buys through an online marketplace. That item is a brand new product. The supply chain doesn't know about the dimension weight of these products. So we through our dimension weighing and scanning system, we collect the digital twin information of the product, make it available for the consumer who's purchased it online, but also the service provider in the supply chain, so they can optimize the transportation, storage, and so forth. The next use case where digital twin in supply chain makes sense is around track and trace. Again, we have a lot of good examples. One of the examples that I want to talk about is recently we had a few years ago, I should say, we had a scenario in Asia where baby's milk product has been contaminated. So by using track and trace technology, authentication technology, RFID technology, we were able to quickly restore a digital representation of that milk product, every single milk product, and do more targeted and specific recall, as an example. The next use case, which is very popular, is around localization. This is about finding where my product is. I want to, especially even in the context of being it in the far end of the supply chains, for example, in the retail store. As a consumer, I want to know where the next pair of jeans is, and for the retailer, it might be inside the store, but if it's not presented to the consumer, it's a loss of sale. So real-time locationing system, localization is very powerful to provide that consumer experience in the case of the retail store. Predictive maintenance. Predictive maintenance uses digital twin along with immersive technologies such as virtual reality and so forth to provide that experience to the customer. So we could seamlessly repair a machine remotely without even being on site, and it helped us greatly as well as our customer in the context of COVID. The last one is in this use case series is about navigation. Navigation for us is providing autonomous navigation within the warehouse or outside the warehouse using our LiDAR scanners, the safety LiDAR scanners, I should say. This allows for human-machine collaboration at workforce. So human-machine collaboration is achieved through a smart navigation system that works in parallel with a human. So continuing with the use cases, we also have other use cases which is getting very popular with respect to digital twin. The first one is the inventory accuracy. You said something?
Oh, sorry, you didn't flip this slide.
Yeah, I did.
Wait, it still stays on DWS. So this is my controlling your reading, but you have to flip this one.
Okay, I'll start.
Start again. Yeah.
I think we finished this one, right?
Yeah, finish the user case, the first slide, the
Yeah.
second one, start again. Okay, 1, 2, 3.
Continuing on with the use cases, we have digital twin being used in inventory accuracy. We have customers using radio frequency identification technology to track their inventory, be it at the item level, carton level, or pallet level. That's another great example of digitalizing your inventory using digital twin. The next area is the shipment verification. As most of you would know, shipping doors, the dock doors, are the most premium real estate in your supply chain. Any technology, especially digital twin, that can be used to optimize these real estate is going to be great for companies. And companies, again, are using a combination of technologies to achieve accurate shipment verification. This is around making sure that the right product is shipped to the right customer at the right time. The next use case is work in process, WIP, production logistics, or so forth. It has a different flavor in different markets. Work in process allows for companies to track their production logistics, so from raw material to the finished goods. And if there is a safety event, or if there is a recall event, they could go back and analyze a specific section of their production logistic rather than do a full burn down of your stock, as an example. Asset management is also very critical. I'm talking about assets in terms of both returnable, reusable assets such as pallets, crates, and so forth, which can be tracked, which can be accounted for in the supply chain, but also your fixed assets such as forklift, pallet jack, stackers, and so forth. You want to make sure that those resources are also optimally used in your warehouse. The last one is of the use case that I'm going to showcase is around master data. Again, master data is a tool that allows for customers to create a digital twin of a product seamlessly, be it capturing the photograph of the product, dimension of the product, the OCRing, what I mean by OCR is all the label information in the product can also be retrieved and stored digitally. So for all these use cases, we have a virtual demonstration. We do have a virtual demonstration of the master data tool in the expo. So please find some time to look forward to that. Okay, so let's jump into some success stories. I'm not going to talk about all the success stories that we have. I'm going to pick a couple of them from the use cases that we talked about. The first one I'm going to talk about is around the asset management. In this case, it's specifically a returnable asset management, which is a pallet, which is a crate, which is a tote or stillages that you want to manage. So there is a number of steps in terms of asset management, especially with respect to digital twin. The first step in the process is how do you create a digital representation of that physical asset that you have? The way that this can be done is have an identifier, and having an identifier such as RFID automatically creates your digital representation of your pallet. The pallet license plate could be PL 2563. That could be created in the digital twin using an RFID system. The next aspect to that is around providing the locationing for the asset. So you want to control these assets. You don't want the asset to be moving around everywhere. So you could use our navigation system for that asset and create a virtual map or a geofence for these assets. So that geolocationing of the assets in combination with navigation allows to have more control of your assets. The next area is around the documentation, especially companies who are heavily regulated or have safety obligations do certainly need to be aware of the documentation processes. And documentation can be achieved in a single space, especially using digital twin. Why do we do all that? So one of the key areas, key aspect of why do we do all this is improve your utilization or the life of the asset. So you want to get more value of your capital investment on these assets. We support that by providing remote services. Remote services is again done through the concept of digital twin. So moving on. Another area I want to talk about is around the analytics part of the assets. So capturing the data of the assets, capturing every movement of your returnable asset allows you to sit back and look at your supply chain processes and then say, maybe this is the area that I want to improve. There is a little bit of dwell time in this area that I want to improve. So those kinds of decisions can also be made using the data that captured with the digital twin technologies. The next use case I want to talk about is around the inventory accuracy. Customers are talking about inventory from two aspects. So most companies in supply chain need to perform an audit once every 6 months or a year, depending upon what industry they are in. So that what we call as the audit cycle. And there are other companies who has to do more frequent stock take, maybe a daily stock take or even twice a day stock take. So that we want what we call as the inventory cycle. So digital twin technology do apply in both aspects, be it in the audit cycle or in the inventory cycle. In the audit cycle, it could be a scheduled event. For example, you could schedule an audit event. You could schedule an audit event. Once that is scheduled, that part of the digital record is now pushed into the operator. So you could see a seamless interaction between the digital world and the physical world, where the scheduling is happening in the digital world, but the operative portion of the audit is happening in the physical world. So this is a classic interchange between the physical and the digital world. In the inventory cycle, it's pretty much the same step. You have more schedules and more operation, but also you could use other techniques such as monitoring and analysis. So, for example, if you have a high value asset or a product that is missing, you could monitor that more effectively using the digital twin technology rather than wait weeks into it and then know a certain product is missing, as an example. So that's another classic example of how digital twin can be used. So there's two use cases we talked about. Now I'm going to call my colleague, Mr. Gary Milburn, to talk about the 3D safety aspect.
Thanks, Praveen. I'll now talk about 3D safety. So talking about the digital twin in the safety world. So I'll run through the challenges that we face when applying safety solutions to an existing piece of equipment, a solution that we have available to help with that, the benefits for customers in utilising this solution, and the outcomes. So the challenge, firstly, is when we have an existing piece of equipment and we want to apply a safety solution to that equipment, how do we actually visualise what that safety concept is going to look like on our machine? So how will it appear? Will it be acceptable for use in the way that I currently use the machine? Will it present any problems upon implementation? So are there any unforeseen ramifications to fitting a safety system to the machine? And how might it affect access to the machine, particularly in respect of the machine operators and how they interact with the machine? And how can we be sure that we actually have all the hazards addressed sufficiently to cope with the safety requirements? So those are the challenges that we face when retrofitting safety onto existing equipment. So the solution that we're going to talk about today is utilising a 3D virtual safety concept of our safety solution. And how we do that is we perform a 3D measurement and imaging and then a realisation of the safety concept onto the machine. And we do that by firstly scanning and mapping the machine and create a complete virtual machine in 3D for us to work with. During that process, we actually document all of the hazards on the machine, and then we can go away once we've actually created this 3D image of the machine. We can actually take that and design a virtual implementation of our safety system as we imagine it might be on the machine. We can also then adjust the design accordingly so that we have some flexibility, of course, at this point to adjust things. And of course, we're creating a complete digital twin of the machine at this point in time as well. So what are the benefits of approaching things this way? So firstly, we can create an accurate digital model of the machine as it's been built in its existing environment. So quite often, otherwise, we're trying to deal with historical drawings, for example, of the machine, which don't actually reflect its current environment. And it's important to actually design a safety solution with the current environment and the current usage of the machine in mind. So during this process, there's no interruption to the production typically or to your process. So all of this can be done actually while the machine is running and in full production. There's reduced engineering complexity as part of doing this process. There's reduced time and cost by specifying and designing correctly the first time. So we have the opportunity to create the design, review the design, and make changes and make sure everything's accurate and as it should be before actually taking any additional steps. It's the best utilisation of resources for material and space. And what I mean by that is that we can actually design the solution appropriately using the correct type of materials, maximising the space available and minimising the space taken up by the safety system. There's less time on site and also less repeat visits to the site to help develop a solution. So typically, otherwise, we might have to actually revisit the site or spend more time there to actually more accurately define the solution. It's a quicker installation time as well, because we have a more accurate solution right from the outset. There's a much quicker installation time. And also we have the benefit of being able to show you or provide the customer with a view of what the safety system will look like by this fly through or walk through the 3D point cloud. So what we're showing here on this slide too is we're showing an example of a 3D scan that was taken at our main warehouse in Germany, and also an image of the scanning equipment that we use in the process. So the outcome is that you have a millimetre accurate digital twin of your machine in its current form. So this actually helps to keep your documentation up to date and revise it according to the current usage of the machine in its current situation. You've got updated and accurate data on your machine as it stands, which may, and quite often is, different to the original drawings of the machine due to modifications over time, for example. There's minimal on-site fabrication and adjustment required as a result of having this digital version of the solution to work with. less time and money spent, as I mentioned earlier, and the implemented solution is the best possible solution. The certainty of compliance with relevant standards at the design stage is another important outcome, because you can actually review all of this during the design, and you have an optimized solution according to the specifics of the machine in its current operation and current situation. And so you actually end up with the highest productivity with a compliant, safe solution.
Safety solution designs and turnkey installations on manufacturing equipment can be complex and difficult to engineer and install. Simplify it by hiring 6 safety services to create a 3D safety concept, which will be a digital twin of your machinery. Using laser scanner technology with 1 centimeter accuracy, we gather point cloud data, which can then be used to design your technical protective measures, such as light curtains, laser scanners, muting sensors, and hard guarding, for example. This way, our 3D safety concepts can be more precise by defining critical mounting distances and guarding measurements in relationship to the relevant standards. The 3D safety concept, offered by 6 safety services, allows for optimization of the safety solution to achieve the highest possible productivity, while also keeping your personnel safe and compliant to relevant standards. We call this safe productivity.
You can see from the video the concept that I'm talking about and how you can actually get a very involved and accurate look at what the solution would look like on your machine. And you can see all of the detail that's involved there in terms of measurements and specifying the different parts of the solution. So just to wrap up, some additional safety services that we have available for you in addition to what we've just talked about today is things like risk assessment, for example. So we can come in and actually perform risk assessment on your equipment, help you out with safety requirement specification. We can do safety design for you. Installation and commissioning services are also available. And then we can come in after a safety solution is implemented to perform things like verification and validation as well. And in addition, we also have quite a broad offering of machine safety training options available for you as well. So hopefully that's given you a good idea of what we can offer in the digital twin concept with the 3D safety services. Thank you.